Hi everybody, we are continuing the notes for O1 recursion notes. This is part 2 of the O1 recursion notes. So just like the other examples, what's the result when truck 30 is called? So in this one, truck 30 returns an integer. It takes in an integer, but it returns an integer as well. So if n is greater than 2, we return 3 plus truck n divided by 2, else we return 5. So let's go ahead and try this one. So for this one, n starts as 30 because we are going to go ahead and call truck 30 first. So if n is greater than 2, which it is, we're going to return 3 plus truck n divided by 2. So we're going to return 3 plus truck n divided by 2, since n is 30, 30 divided by 2 is 15. Now we have to do truck 15. So we replace the n with 15. And so if n is greater than 2, so in this case 15 is greater than 2, we're going to go ahead and do 3 plus truck 15 divided by 2 is, now remember, integer divided by integer is integer, so it's not 7.5, it's 7. So now we have to evaluate truck 7. So we'll go ahead and plug in 7 for n. If n is greater than 2, which it is, so we'll return 3 plus truck 7 divided by 2 is 3. So we'll now do truck 3. So go ahead and for n, plug in 3. So truck 3, if n is greater than 2, since it is, we're going to go ahead and once again do 3 plus truck 3 divided by 2 is 1. And then we'll go ahead and do that. So now we have to do truck 1. So because n is 1, we'll just plug that in. And in this case, n is 1, which is not greater than 2, so it says else return 5, so we end up returning 5 from this. So in this case, unlike the other examples, this is returning an integer. So really it's just going to do 3 plus whatever the result of truck 15 is. Truck 15 is 3 plus whatever the result of truck 7 is. Truck 7 is 3 plus the result of truck 3. Truck 3 is 3 plus the result of truck 1. And the result of truck 1 is 5. So once again, you can actually use your little smiley face method once again. And this time, because there's an operation here, well, remember, just go left to right like this. Because of this operation, we actually add the numbers this time. So what we'll do is we'll do 3 plus 3 plus 3 plus 3 plus 5. And that's going to give us whatever our answer is, which is 17. And so our final answer is going to be 17. Let's go on to the next example. So for our final example, we have the output of starboard 5. This one is probably the trickiest one because we have a method call followed by another method call. So this can get a little bit messy. So what I would suggest that you do on this type of problem is use lots and lots of paper. Maybe even use an entire sheet of paper to do this whole problem. And you'll see why in a minute. It gets very layered. So let's do this. Starboard 5. Well, plug in n equals 5. If n is greater than 2, we'll go ahead and do starboard n minus 1. So that's going to be starboard, and then starboard n minus 1 is 4. Then we print 4 I'm sorry, we print 5 because that's a value of n, and then we do starboard n minus 1. Since it's 5, 5 minus 1 is 4. Now notice how I've spread this out a lot. I would suggest you do the same because with each of these method calls we're going to have to do more stuff. So let's call starboard 4 now, because that's the method we have to call. So we'll go ahead and plug in 4. So since 4 is greater than 2, we'll go ahead and call starboard 4. So 4 is greater than 2, enter the if statement. So this is going to be, I'm just going to write star for short, although you should know it means starboard. So starboard 4 minus 1 is 3. Then we print n, which is 4. And then we do starboard n minus 1 is 3. Now print 5 doesn't really do anything except print the number 5, but we have to call starboard 4 again, which means we actually have to do the same thing on the other side. So let me just do that really quickly. There we go, the magic of video. So we just do the same thing for this other side, but now we have to go ahead and call star 3 or starboard 3. So let's do that now. So I'll just go ahead and plug in 3. So 3 is greater than 2. So we'll do starboard n minus 1. So since n is 3, starboard n minus 1 is starboard 2. Then we have to print n, which is 3, and then do starboard 2 again. Let me line this up a little better. And because I'm starting to run out of space, I decided to abbreviate print as just PR, so just know that PR just means print. So now that I made the call for starboard 3, I have to do that for all the other times that starboard 3 is called. So I'll just have to draw those out as well. Let me do that at this time. Once again, the magic video seems to save the day again. So let's continue. So now we'll go ahead and do int n is 2. So let's see, because we're doing star 2, we have to plug in n equals 2. But 2 is no longer greater than 2, so it looks like star 2 actually doesn't really do anything, doesn't actually produce any output. So we could actually just cross these ones out, because they don't really do much. Then finally, after we've done all this, we have to figure out, okay, what is the order in which the numbers are printed? Well, let's ask you this question first. What number do you think prints exactly in the middle? It looks like 5 prints in the middle because we have to do starboard 4 first, then print the 5, and then do starboard 4 again. So what does starboard 4 do? Well, it prints 4 in the middle, does starboard 3, and then after it prints the 4, it does starboard 3 again. And starboard 3 just prints the 3. And as you can see, it does the same thing on this side. So I just go ahead and use the smiley face rule again. It's just that it's like kind of a grooved smiley face, so I have to go like kind of along the edges, add little bits of teeth, you know, so it's kind of more like a grooved smiley face now. So I have to go like kind of like this way. And then go back all the way up to the top. And as you remember, it's going like this. So let's just follow it. So there's no prints. Oh, we see a print right here. So it starts by printing the number 3. And then it'll print the 3, then print a 4, and then print another 3. Then after that, it goes in here to the middle, prints a 5. Follow the grooves of the smiley face to print a 3, and then another 4, and then a 3. So just to trace that through again, we're going to follow the groove down to print 3, 4, 3, 5, print 3, print 4, and then print 3, and then go back up to the top of the smiley face, and there are no prints there. So this is basically going to be our output right down here. That is it for the recursion notes. Go ahead and do the recursion worksheet now that's associated with this. Thank you.